Now, finally, the last form is what we call KE, or kinetic energy. If you push on an object and you get it moving, whee, like these little toy cars and stuff, you set it in motion. And then that object can hit something and then do work in return. So the whole point is that energy is stored up. That's called kinetic energy. But if you substitute in work is force times distance, F equals ma, assume the acceleration is constant, you could put in a nifty equation, you end up getting this. It's kind of common sense, but this looks kind of like the spring potential energy equation. And that is the kinetic energy is equal to half the mass of an object. But then the big thing is it's actually velocity squared, which is kind of interesting there. So in other words, which has more kinetic energy usually? A truck driving on a highway at 50 miles an hour, or a normal passenger car, a Honda Accord going 50 miles an hour? Which one's got more energy? Obviously the truck, because it's so massive, right? If a truck is, I don't have a truck, but that's okay. If a truck has twice the mass as a car and they're driving at the same speed, the truck's going to have twice the kinetic energy. So that's why accidents on the highway involving trucks and SUVs are very dangerous, because there's a lot of energy involved. But on a highway, accidents are especially dangerous because people are driving so what? So fast. So is there any way a little tiny Honda Civic can have as much energy as a big tractor trailer, a big semi? Yeah, if it was driving faster. So in fact, if this car is now driving 100 miles an hour, okay, which is very dangerous, right? It wouldn't have twice the kinetic energy, but its velocity what? Squared. You see that? So what would be twice the speed? What's 2 squared? It would be how much more energy? 4 times the energy, exactly. So you ever notice on the side of the highway, there's these barrels? You guys ever notice that? Anyone notice inside those yellow barrels? It's actually, yeah, just barrels full of water. How come? Well, that way, if you're thirsty, you can just pull over, right, and get a drink. The barrels are filled with water. Why would you do that? It's not to get a drink or emergency porta potty, but sure. Yeah, exactly. If you're driving and you lose control, instead of slamming into concrete, it's really dangerous because the kinetic energy of your car is turned into work on, the concrete barrier or whatever. And then that does a ton of work on your car in return, Newton's third law, action-reaction, and then there's a lot of damage done. So the idea is if you can dissipate that work slowly over time by crashing into barrels full of water, you safely dissipate that kinetic energy. And then most cars are designed to crumple. That's why it looks so bad in an accident, so that the car absorbs the energy and not the passengers.